Right. In this lecture, we will start with the course of signals and systems. Okay. So the textbooks which I will follow are Signals and Systems by Oppenheim, Wilsky and Nawab. Okay. So this is second edition is available. I'll follow this textbook. Along with that, the same title, Signals and Systems. Okay, Simon Hakin and Van Veen. Okay, third edition is available for this. So we'll follow these two textbooks very closely in understanding the concept of signals and systems. Okay, so let us start with the definition of a signal. So how do you define a signal? A signal is a function. Okay, so a signal is a function, okay, which varies with respect to one or more independent variables. Okay, one or more independent variables. So we define a signal as a function which varies with respect to one or more independent variables. Okay, so that is the definition of a signal. Okay, so next, the number of independent variables. Okay, so the number of independent variables on which the signal is dependent. Okay, so the signal is dependent is called dimension of the signal. Okay, is called dimension of the signal. So how do you define a dimension of a signal? It is the number of independent variables on which the signal is dependent. So it is called dimension of the signal. So for example, if you say, if you take like x of t equal to cos t, okay, t square and so on, all these are one dimension signals. Why? Because t is the only independent variable on which the signal is dependent. Okay, similarly, if I take f of x comma y equal to, let us say, x square plus y, or if we take xy, all these guys are examples of two dimension signals. Okay, similarly you can have many more examples with many dimensions. So for example, f of x comma y comma z is x y z square comma x plus y square plus z cube and so on. So all these are three dimension signals. So like that we can have n dimension signals and also infinite dimension signals. But as far as this course is concerned, we will be dealing only with one dimension signals. Okay, we will be dealing only with one dimension signals also. So in signals and systems, we deal only with single valued signals. Okay, we deal only with single valued signal. Okay, we deal only with single valued signal. So what do you mean by this? So the amplitude of signal can take only one particular value at any given instant of time. So all these like for example, x of t equal to t, t plus 4, t cube, and all these fellows are examples of single value signals. Okay, so at any given instant of time it can take only one value. So for example, if you take x of t equal to t, so x of 0 is 0, x of 1 equal to 1, and so on. So all these are examples of single dimension signals. So as far as signals and systems is concerned, we'll be dealing only with single valued and single dimension signal. Okay, so based on this we classify. Okay, so based on this we classify the signals into 6 categories. Okay, so we will see that. So next we move on to what is called classification of signals. So next let us move on to classification of signals. Classification of signals. In this we deal with classification of signals. Okay, so first one we talk about what is called even and odd signals. Okay, so even and odd signals. Okay, so before we see even and odd signals, there is one more classification. So first let us talk about that. Okay, so first let us talk about the first classification, which is okay, so first classification will be continuous time and discrete time signals. So first let us talk about what is called continuous time and discrete time signal. So how do you define a continuous time signal? We define a continuous time signal as x of t. Okay, so continuous time signal we define it as x of t. Similarly we define a discrete time signal as x of n. Okay, so we define it as a x of n. So we use always parentheses to represent a discrete time signal, and we use square bracket to represent a discrete time signal. Okay, so here the t can take any number and the real line. So what does it mean? So it can take any value between minus infinity to infinite, but here n can take only integer values. For a discrete time case, the n can take only discrete values. And what about the amplitude of the signal? The amplitude of the signal can be complex. So here also the amplitude of the signal can be complex. Okay, so if you want to plot any continuous time signal, it will look something like this. Okay, so this is the way how you plot a continuous time signal. So this is just an example. For a discrete time signal, it is defined only at discrete instance of time, so it will look something like this. Okay, so this is the way how you plot a discrete time signal. Okay, so that's about the first classification. That's the easy one. The second classification we talk about what is called even and odd signals. That is called even and odd signals. Okay, so we define a signal x of t to be even if x of t equal to x of minus t. Okay, so when do I say its signal is even? if x of t equal to x of minus t. And when do we say signal is odd? If x of minus t equal to minus x of t. Okay, so if x of minus t equal to minus x of t, then we say that the signal is odd. So for discrete time case, how do you say a signal is said to be even if x of n equal to x of minus n, and it is said to be odd if x of minus n equal to minus x of n. Okay, so if you take an example for a continuous time case, so it will be like x of t equal to cos t, t square, and so on. Okay, so these are examples of even signals. So what are the examples of odd signals? So they will be sin t, t, and so on. Similarly, for continuous time case, x of n equal to cos pi n comma 1 and so on. Okay, so 1 is a DC signal, which is also an even signal. So similarly, x of n equal to sin pi n by 3 n cube and so on, all are examples of odd signals. Okay, so for example, in general, what happens, a signal can be neither even nor odd. So in general, signals are neither even nor odd. Okay, so in general, the signals are neither even nor odd. Okay, but they can be split into even and odd parts. Okay, but they can be split into even and odd parts. Okay, even and odd parts. Okay, how do we do that? We do that in this way. How do that? X of t equal to xe of t plus xo of t. X of t equal to xe of t plus xo of t. So let me call this equation 1. Okay, so we can split the signals into even and odd parts as follows. What is that? X of t equal to xe of t plus xo of t. So xe of t stands for E stands for even part, and O stands for odd part. So same rule can be applied for discrete time. So we can write it as x of n equal to, or else we'll write it on the next page so that it will be clear. Okay, so for odd part, for discrete time case, how does that look? For a discrete time case, x of n can be written as xe of n plus xo of n. Okay, x of n is equal to xe of n plus xo of n. Okay, right. So what are these equal to? We will write on that. Where xe of t equal to x of t plus x of minus t by 2, and xo of t is x of t minus x of minus t by, okay, which is x of t. Okay, x of t minus x of minus t by 2. Okay, so for example, if you take x of t is equal to 2 cos t plus 3 sin, Okay, so clearly for this x of minus t will be equal to 2 cos t minus 3 sin t. So clearly what will be our xc of t? Xc of t is nothing but x of t plus x of minus t, implies what happens? X of t plus x of minus t by 2. So if you add these two guys, 3 sin t will get cancelled out. If you add these two guys, you'll get 4 cos t divided by 2, which is nothing but 2 cos t. Similarly, you can get xo of t to be equal to this minus this. So if you subtract this from this, what will happen? This will get cancelled out and they will get 6 sin t by 2, which is nothing but 3 sin t. So for the given signal x of t, even part is 2 cos t and odd part is 3 sin t. Okay, similarly for discrete time case, okay, so we'll take another example. So this is for discrete time case. So what happens? Let us take x of n to be n square cos pi n by 3 plus 1 plus n square into sin pi n by 4. 1 plus n square into sin pi n by 4. So for this, what will be our x of minus n? X of minus n would be equal to n square into cos pi n by 3 plus 1 plus n square into sine of pi n by 4. If you will place minus, it will become minus. Okay, sine of pi n by 4. So this will be minus. Okay, so what will be our xe of n for this case? So xe of n would be equal to x of n plus x of minus n. Clearly the second term will get cancelled out. So this will be equal to n square cos pi n by 3, and similarly xo of n would be equal to, you subtract one from the other, so obviously first term will get cancelled out, the second term remains. So this will be equal to 1 plus n square into sine pi n by 4. So this will be our odd part. Okay, so how do you, let us try to see more examples so that you are thorough in this concept. Okay, so we will see many examples for both discrete time case and continuous time case, but step by step we will move on. Okay, so before we see examples, let us see few important things. So what are they? So what are they? Okay, so note, first note is, so if you add two even signals, okay, so addition of two even signals result in even signal. Okay, so addition of two even signals results in even signal. Okay, addition of two even signals will result in even signal. Similarly, addition of two odd signals, addition of two odd signals result in odd signal. Okay, so addition of two odd signals result in odd signal. Similarly, multiply two even signals, that is even signal multiplied with even signal. Okay, so results in even signal. So even multiplication of two even signals results in even signal. Similarly, you can say that or the product of two odd signals, okay, so odd signal into odd signal, that will result in even signal. Okay, so that will result in even signal. And finally, what is that? So if you multiply an even signal, okay, so with an odd signal, okay, so you get an odd signal, you get an odd signal. Okay, so we will see this with simple examples. Okay, so we'll see this with simple examples. Okay, right. So if you take x of t to be equal to cos t plus t square. So if you look at this, so this signal is an even signal and this signal is an even signal. So what happened? So finally the resulting signal is also even signal. Okay, so we will take this as first example. Second one, so if you take x of t to be t square sin t plus t cos t. So clearly this signal is odd, this signal is odd, this resulting signal will also will be odd. Why? If you add two odd signals, you should get back the odd signal. Okay. Similarly, as third example, to take x of t to be equal to cos t plus sin t. So if you look at this, so this fellow is odd, this fellow is even. So clearly, this signal is neither even nor odd. Okay, so neither even nor odd. Okay, so for a discrete time case you can take, so this till now we have seen for continuous time case. Okay, so these are the examples for continuous time case. So for discrete time case, what happens, let us see. Okay, so here we take the first example to be x of n equal to cos pi n by 4 plus minus 1 power n. Okay, so clearly this fellow is even, this fellow is even, and hence this fellow is also even. Okay, so cos pi n by 4 plus minus 1 power n, that is an even signal. So as a second example, we take x of n to be equal to n cube cos pi n by 4 plus n sin 3 pi n by 4. Okay, so this fellow is odd, this sorry, this fellow is odd, and let us take this to be mod n into sin 3 pi n by 4. So this fellow is odd, so this fellow is also odd, and hence the resulting signal is also odd. So as a final example, we take x of n to be cos 3 pi n by 7 plus sin 6 pi n by 11. Okay, so this fellow is odd, this fellow is even, so this fellow is neither even nor odd. Okay, so this fellow is neither even nor odd. Okay, so these examples will tell you as far as additions of two signals are, two even signals or two odd signals are concerned. Okay, so next let us take an examples of products. Okay, so let us take an example of product. Okay, so this is as far as addition is concerned, correct? So this is as far as addition is concerned. So now let us take the examples for products. So this is for additions and this is for products. Okay, so again for continuous time case, the first example, let us take x of t is equal to t square sine of t square. Okay, so it's t square into sine of t square. So clearly this function is even and this function is also even. So clearly the resulting signal is an even signal. Okay, second example, we take x of t to be equal to t cos t. Okay, again this fellow is even, this fellow is odd, so product of even and odd signals should be odd signal. So as a final example, let us take x of t to be equal to t cube sine t. Okay, so again this fellow is odd, this fellow is odd, the resulting signal is even signal. So this is for continuous time case. So now let us take it for discrete time case. Okay, so here let us take the first example to be x of n equal to 1 plus n square into cos of pi n by 7. Okay, cos of pi n by 7. So this fellow is even, 1 plus n square is even, so obviously the resulting signal x of n is also even. Okay, as a second example, we take x of n to be n cube into minus 1 power n, n cube into minus 1 power n. So this fellow is even, n cube is odd, so obviously resulting signal is also odd. Okay, so as a final example, let us take x of n to be equal to n into n cube, which is clearly n power 4. So note that this fellow is odd, this fellow is odd, and this fellow is even. Okay, so these are the few examples to say that product of two even signals is even, product of two odd signals is even, products of even and odd signal is odd. Okay, now let us see one more important note. So it looks simple, it's important. Okay, so what does it say? Okay, so what is another note? What is another note? Okay, so for any odd signal, okay, so its value at origin will be equal to 0. We know this, but still is 0. Okay, so what does it mean? X of 0 equal to 0. So this is for continuous time case, or x of n equal to 0 for discrete time case. So provided the signal x of t or x of n is odd, correct? So that is, if x of t is odd, x of 0 equal to 0, or if x of n is odd, then we say x of n is equal to x of minus n. Okay, that is important. Okay, right. So now let us proceed with few examples. Okay, so let us proceed with few examples. We'll see many examples so that this concept will be clear for us. Right. So let us take, question will be find even and odd parts of a signal, odd parts of the following signals. Find even and odd parts of the following signals. Following signals. Okay, so we will see one by one. First one, let us take x1 of t to be equal to t into 2 minus t into 1 plus 4t. Okay, so that is our signal. Let us try to find the even and odd parts of the signal. So if you expand this signal, you can easily see that this is nothing but 2t plus 7t square minus 4t cube. Okay, clearly for this x e1 of t, or we can write it as, another way of writing this is even part of x1 of t will be equal to, by inspection you can directly see that this is equal to 70 square. Similarly, you can see that odd part of x1 of t will be equal to 2t minus 4t cube. Okay, so 2t minus 4t cube. As a second example, let us take x2 of t to be equal to 2t square minus 3t plus 6 by 1 plus t. So here inspection will not help, will take, so obviously we have to carefully solve this. Okay, so this is our x2 of t. So what will be our x2 of minus t? So that will be equal to 2t square plus 3t plus 6 by 1 minus t. Okay, into divided by 1 minus t. So obviously, so what will be our even part of x2 of t? So that is nothing but x2 of t plus x of minus t by 2. So if you expand that, so this will be 1 by 2 times 2t square minus 3t plus 6 by 1 plus t plus 2t square minus 3t plus 6 by 1 minus t. Okay, so if you cross multiply and simplify, so this will be equal to 5t square plus 6 by 1 minus t square. Okay, so 5t square plus 6 by 1 minus t square. Similarly, you can see that add part of x2 of t. How do you get this? This is nothing but x2 of t minus x2 of minus t by 2. So this is nothing but 1 by 2 times 2t square minus 3t plus 6 by 1 plus t minus 2t square minus 3t plus 6 by 1 minus t. Okay, so if you simplify, this will be equal to 2t cube plus 90 by t square minus 1. Okay, that will be 2t cube plus 90 minus t square minus 1. So how do you cross check it? So just note that even part of signal should be even. So we replace t with minus t here and t with minus t, will get back the signal. Similarly, if you replace t with minus t here, you will get back the signal to be odd. So this is one way of cross checking the answer. Okay, so this is our even part and this is our odd part. Okay, right. So we will take one more example. Third one, x3 of t is equal to 1 plus t square sine 3t plus t cos 4 t square. So clearly again we can use inspection for this. We get even part of x3 of t to be 1 and odd part of x3 of t to be equal to t square sine 3t plus t cos 4 t square. Okay, so odd part of x3 of t can be written as t square sine 3t plus t cos 4t square. Okay, so we will see one more example. Let us proceed to the next page. Okay, so fourth example. Okay, so let us take the fourth example. So what is that? x4 of t is equal to 1 plus j into e power jt e power, let us say, j4t plus cos of 3 pi t by 4 plus pi by 6. So for this, what is x4 of minus t? This will be equal to 1 plus j into e power minus j4t plus cos of, we replace t with minus t, I'll get 3 pi t by 4 minus pi by 6. So what is our even part of x4 of t? So that will be equal to 1 by 2 times 1 plus j is common into e power j4t plus e power minus j4t plus cos of 3 pi t by 4 plus pi by 6 plus cos of 3 pi t by 4 minus pi by 6. So this is clearly 2 cos 4t divided by 2. This will be equal to 1 plus j into cos 4t plus, so cos a plus b plus cos a minus b will be 2 cos a cos b, that 2 and this 2 will get cancelled. I'll get finally cos of 3 pi t by 4 into cos 30. So cos 30 is nothing but root 3 by 2. So I'll put it here. Simply plus root 3 by 2 cos 3 pi t by 4. Similarly, odd part of x4 of t this will be equal to again 1 plus j times j sine 4t minus 1 by 2 sine 3 pi t by 4. You can simplify and get the answer. Okay, 1 by 2 sine 3 pi t by 4. Okay, right. As a final example, let us take fifth one to be x5 of t is equal to 1 by a plus jb t. So clearly what is x5 of minus t? So that will be equal to 1 by a minus jbt. So what is even part of x5 of t? So even part of x5 of t will be 1 by 2 times x5 of t, which is 1 by a plus jbt plus x5 of minus, that is 1 by a minus jb. So expand this is nothing but a by a square plus b square t square. Similarly, odd part of x5 of t will be equal to 1 by 2 times 1 by a plus jbt minus 1 by a minus jbt. So if you simplify, this will be equal to minus jbt by a squared plus b square t square. Okay, so we'll get odd part of that will equal to minus jbt by a squared plus b square. So all these examples are concerned with algebraic notation. So what will happen if we use graphical signals? Okay, so we will take those examples also. Okay, so again we will proceed with that, finding the even and odd parts of the signals. Okay, so let us take the first signal to be this one. Okay, so this is our x1 of t. Okay, so let us try to find the even and odd part of this signal. Okay, sorry for that. Okay, so let us take our x1 of t to be this guy. Okay, so this is our x1 of t. Okay, this is 0 and let us take this to be 1, 2 and this to be 1. Okay, so if you see this signal, equation of this line would be minus t plus 2 and equation of this line would be t. Okay, equation of that line would be t. So what will be our x1 of minus t? X1 of minus t is nothing but the flipped version of this signal, right? So x1 of minus t will look something like this. So this is our origin, so this is 1 and what will be equation of this line now? It will be minus t and the equation of this line will be t plus 2. So this will be minus 2, minus 1 and 0. So if you add these two signals, we get even part. So let us try to plot even part of x1 of t. So what does it say? Even part of x1 of t is nothing but x1 of t plus x1 of minus t by 2. So how does that look? So even part of the given signal will look something like this. Okay, so even part of the signal will look something like, so this will be your origin t1 2. Now what about amplitude? x1 of t plus x1 of minus t by 2. So that will remain at half. Okay, so that will be equal to half. So what will be equation of this line? This will be minus t plus 2 by 2. Equation of this line will be t by 2. Equation of this line will be minus t by 2, and equation of this line will be t plus 2 by 2. So equation of that line will be t plus 2 by 2. Similarly, how do you plot the odd part? So odd part will look something like this. Okay, so odd part of x1 of t will look something like this. Okay, so what is odd part? X1 of t minus x1 of minus t. So if you subtract x1 of minus t from x1 of t, so what do we get? This whole signal will get reversed to the negative direction. So my odd part will look something like this, and for positive time the plot will look like this. Okay, so this will be 2 1 0 minus 1 and minus 2. Again amplitude will be equal to half, and for negative direction will be minus half. So what will be equation of this line? Equation of this line would be t by 2, and equation of this line will be as usual minus t plus 2 by 2. And what happened to the equation of this line? This will be minus t minus 2 by 2. Okay, the equation of that line will be minus t minus 2 by 2. Okay, right, so we'll take one more example. Okay, so let us take x2 of t to be this signal. Okay, so let us take x2 of t to be this signal. Okay, let us take this minus 1 1 t and 1. Okay, so that is our x2 of t. So what will be our x2 of minus t? So let us finish off the equation for this. So equation of this line would be 1 plus t. Okay, so equation of that line would be 1 plus t. So now let us plot x2 of minus t. So that will be just flipped version of the original signal x2 of t. So how does that look? So it looks something like this, correct? Okay, so this is minus 1 1 and 1. So this is our x2 of minus t. Okay, so what does, again we have to plot the even part of signals. Obviously x2 of even part is given by x2 of t plus x2 of minus t by 2. So what will happen if I add these two signals? Okay, so how does the plot look? So let us see how does the plot look. So from minus 1 to 0, this is 1 and this is 1 plus t. If you add those two guys, you will get 2 plus t. Okay, so just before minus 1 the signal is 0, just after 0 it is 2 plus t. So obviously what will happen? The signal will jump by a factor of 1. Okay, so it will jump by a factor of 1, and then it is a straight line. So it will look like this, and from 0 to 1, what will happen? So what will be equation of this line? This will be 1 minus t. So 1 minus t plus 1 will be 2 minus t. So it will be like this, and then it will fall down, and overall signal should be multiplied by half. So what will happen? So this amplitude will be 1, this amplitude will be half, and the equation of this line would be 2 minus t by 2, and the equation of this line will be 2 plus t by 2. Okay, so equation of that line will be 2 plus t by 2. So this is our even part. So the time limits will remain same at minus 1 and plus 1. Okay, so this is our even part of x2 of t. Okay, so that is our even part of x2 of t. So similarly, let us try to plot the odd part of x2 of t. So how does that look? So let us take this to be t. So now what is odd part? X2 of t minus x2 of minus t. So what will happen? 1 plus t from minus 1 to 0, this is 1 plus t, minus 1 to 0, this is 1. If you subtract 1 from that, I will get just t. So how does that look? T, and your overall signal should be divided by 2. So obviously how does that look? It will be like this. Okay, it will be like this. Next, 0 to 1 it is 1, 0 to 1 it is 1 minus t. So 1 minus of minus t will be again t. So obviously my signal will look something like this. Okay, so this will be minus 1, this will be minus half, this will be 1, and the equation of this curve would be t by 2. So this is our odd part of x2 of. Okay, so this is the way how you plot the even and odd parts of a signal. Okay, so now let us proceed for a discrete time case. Okay, so let us try to do the same thing for discrete time case. Okay, so let us see that on a fresh page. Okay, now let us consider my signal x of n to be this guy. Okay, so this is my x1 of n. So let us take this signal to be this guy. Okay, so this is 0, 1, 2, 3, 4, 5, minus 1, minus 2. Let us take this amplitude to be 1, and let us take this amplitude to be minus 1. So this fellow amplitude is minus 1, and this fellow all these fellows are having same amplitude of 1. Okay, so let us try to plot x2 of x1 of minus n. So x1 of minus n, how does it look? It is just the flipped version of our original signal x of n. So if you flip it, what do you get? So you'll get 1, 2, 3, 4, and minus 1, 4, minus 1. Okay, so it will be 0, 1, 2, minus 1, minus 2, minus 3, minus 4, minus 1. Okay, so this is our x1 of minus. And so what is the even part of the signal? We have to just add these two guys and divide by 2. So if I add these two guys and divide them by 2, what will I get? Okay, what will I get? So for this signal, if you look at it carefully, so at minus 3, minus 4, and minus 5, all these amplitudes are 0. So 0, minus 1, right? So this amplitude will be minus 1, and this amplitude is 1. So 0 minus 1 will be minus 1, minus 1 by 2 will be minus half. So how does that look? So overall signal will look something like this. Okay, at minus 2, what will happen if I add those two guys? So this signal will not be there, right? So at minus 2, what happens? This is 1, at minus 2 this is minus 1. So 1 plus of minus 1 will be equal to 0. So clearly you won't have this plot here. Okay, so at minus 2 it will be 0. So at minus 1, 0, 1. Again at 2, what happens? This flow is 1 and this flow is minus 1, so it will be equal to 0, and then it will be like this. Okay, so this amplitude will be half and this amplitude will be minus half. So this is our even part of x1 of n. Similarly, what will be the even part of, odd part of x1 of n? How do we get that? This minus x1 of n minus x2 of n. So how does the plot of that guy look? Okay, so this is our odd part of x1 of n. So how does that look? So just let's this will write minus 2, minus 3, minus 4 and minus 5. This is 1, 2, 3, 4, 5, 3, 4, 5. So obviously this flow will not exist, correct? So here also we'll have only 3, so this side also will have only 3, so this flow does not exist. Okay, okay, so that will be the event part. Similarly the add part, how does it look? So that minus this, so 0 minus of minus 1 will be plus 1. So how does that look? Okay, so this at minus 2 what happens? That is 1, this is minus 1, so 1 minus of minus 1 will be 2, 2 divided by 2 will be 1. Okay, so this is at minus 2, at minus 1 again it will be 0, next at 0 it will be 0, at 1 it will be 0, and at 2 what happens? It is 1 minus of minus 1, that will be minus 1. Okay, then at 3 it is minus half, 4 minus half, 5 minus half. So, okay, so this is 1 and this is half, so this is minus 1 and this is minus half, so this is 0, 1, 2, 3, 4, 5. Similarly this will be minus 1, minus 2, minus 3, minus 4 and minus 1. Okay, so those are the even and odd parts of that corresponding signal x1 of n. Okay, so again we'll take one more example so that this will be clear for. Okay, right. Okay, so x2 of n let us take on the right hand side. So let us try to plot the even and odd parts of the signal. Okay, so this is our x2 of n. So its value, let us take its value at minus 2 to be minus 1. Okay, next at minus 1 to be 2, next at 0 to be 1, at 1 to be 1, at 2 to be 1, at 3, 4 and 5. Let us take them to be minus 1. Okay, so let us extend this axis here. Okay, so we will extend this axis. Let us take this to be n. Okay, right. So let us try to evaluate the even and odd parts of this signal. Okay, so clearly this will be 2, 1 and so on. Okay, so first step is to find x2 of minus 1. If you plot x2 of minus 1, how does it look? So let us try to plot x2 of minus 1. x2 of minus 1. So how does that look? So it will look something like this. So this is minus 1, 0, 1, 2, minus 1, minus 2, at minus 3 it will be minus 1, minus 4 it will be minus 1, at minus 5 it will be minus 1. So minus 3, minus 4, minus 5, it is minus 1. Okay, so these amplitudes are 2, 2, 1 and minus 1. Okay, so this is our x2 of minus 1. So let us try to plot the corresponding even and odd parts. Okay, so if you plot them, how does that look? So this is our n. Okay, so this is, we are plotting the even part of x2 of. Okay, so we are plotting even part of x2 of n. So what will happen? We have to add x1 of n, sorry, we have to add x2 of n with x2 of minus n. So if I add those two guys, what will happen? So from minus 5 to minus 3, x2 of n is 0, right? So from minus 5 to minus 3, x2 of n is 0, but minus 5 to minus 3, it is minus 1. So 1 plus of minus 1 is minus 1, divided by 2 will be half. Okay, so we will get this here. Okay, so this is minus 5, minus 4, minus 3. Then at minus, so these amplitudes will be minus half. Okay, so those amplitudes will be minus half. So what about the amplitude at minus 2? It's clearly it is 0. Why? If you add those two guys, it will be 0. Next at minus 1, what will happen? It is already 2. This is 2, so 2 plus 2 is 4. 4 divided by 2 will be 2. So this is 2. Next at origin, so this is minus 2 minus 1. Next at origin, what happens? It will be 1 plus 1 divided by 2. So that will be equal to 1. Right? So next at 1, again it is 2 plus 2 by 2, which is 2. So this is 1. Next at 2, it will be 0. Correct? At 3, it will be minus half again. At minus 4, minus half. So this is 3, 4, 5, and this will be minus half. So this is our even part of x2 of n. Okay, so clearly if you look at the signal, it looks even. Correct? Right. So next let us try to plot the odd part of the signal. Okay, so let us try to plot the odd part of the signal. So what is the odd part of the signal? That is nothing but x2 of n minus x2 of minus n. So if you subtract x2 of n, correct, from x2 of, if you subtract x2 of minus n from x2 of n, what does we get? Right, from again minus 3 minus 5 to minus 3, this is 0, minus 5 to minus 3, it is minus 1. So 0 minus of minus 1 would be 1. So obviously 1, and we have divided by 2. So obviously the odd part will look something like this. Okay, so this is minus 5, minus 4, minus 3. Next at minus 2, what happens? This fellow is minus 1, and minus of minus 1 would be, so this is 1, right? So minus of minus 1 would be minus 1, minus of minus 1 would be minus 2, minus 2 by 2 will be minus 1. Okay, so this will be minus 1 at minus 2. Next at minus 1, it is 0 clearly. Next at 0, it is 0. Next at 1, it is 0. Next at 2, what happens? So this fellow will become, at 2 this is 1, and the 2 this is 1. At 2 this is minus 1. So 1 minus of minus 1 will be 2. 2 by 2 will be 1. Okay, so this will be 1. Next at 3, this will be minus half. At minus 4, and minus. So this is 0, 1, 2, 3, 4, 5. So these amplitudes will be minus half. So here these amplitudes will be half. So this is our odd part of the signal x2 of n. Okay, so let us stop this lecture here, and in the next lecture we will be continuing with the conjugate symmetric and conjugate anti-symmetric parts, and along with that we will see the periodicity of the signal too. Okay, thank you.